All right, so today we're going to talk about scatter plots and correlation. So correlation is how things are related to each other. Scatter plots are plots that are scattered. So let's go ahead and create a scatter plot. So what you're going to do is just take your pencil real quick and just make dots going up, but kind of scattered, generally scattered away from each other like mine. So something like that, okay? So they're scattered, but they're going up, okay? Then what you're going to do here is you're going to do, again, still scattered going up, but very close to each other. So like this. So they're still kind of like a couple of dots, but they're less further away. And actually that leads me into the definition of line of best fit. So you'll be given a scatter plot, and then from that you'll create a line of best fit. What you want to do is split the dots the best you can on both sides. So what I mean by that is I'm going to draw a straight line, which is a linear, right, going up like this, and I'm going to do it right in the middle and split the dots as best as I can. Now I'm going to show you this a little bit later, but we're going to do it with a calculator. So boom. That's actually not good, because look, don't draw what I just did, because look, in mine I've got like more dots over here than I do over here. So this is not the line of best fit. It's a little bit too high. So I'm going to do that again and bring it kind of over here. That's better. So if you look at it, right, it's split in both directions. So this is called a line of best fit. But the dots themselves are the scatter plot. And the question they'll ask you is, they'll give you these bunch of dots and said, what is the relationship? Okay, so what you're going to say is that there's a positive because it's going up. There's a positive correlation. So let's go ahead and write that down. Actually, both of these are positive. So let's write it here. Positive correlation. And what that means is, as X, I'll do it here. As X is increasing, so as we go this way, what is Y doing? It is also increasing. All right, so a positive correlation means that as X is increasing, Y is increasing. As X is increasing, Y is increasing. So if we're making a line of best fit here, remember, again, splitting the dots as best as you can equally on both sides. Boom, something like that. Yep, that looks about right. We split the dots. Now, what can you tell me about the difference between this scatter plot and this one? Well, these dots are closer to the line, right? They're kind of more perfect, but these ones are scattered. And that's what you need to know. So even though this is a positive correlation, this is called a weak positive correlation. And the reason it's called weak is because the dots are further away from your line of best fit. Whereas this one is a strong correlation because all your dots are close to your line of best fit. All right, so let's go ahead and write that out. So this one is a weak correlation, and you say dots are further away. All right, and then this one is a strong, let's write that here, strong correlation. And I say dots, but you can say data, points, anything like that. Dots are close together. All right, so I'm going to say it again. All right, there are two ways that you're going to describe it, so both have to be in the sentence. This is a positive weak. Positive because it is going up. Weak because the dots are further away. This is a positive strong. Positive because it's going up. Strong because they're more closely together. Okay, so now that we know that, we're going to so we did a positive correlation, so let's go ahead and make a negative correlation. So this one's a negative correlation. All right, and if we're making a negative correlation, which direction does it go up? If positive is going up, then negative must go down. Now we're going to kind of keep this the same way. So we're going to make this side weak. So we're going to make this one weak, and we're going to make this one strong. Okay, so what does weak mean? The dots are farther away from the line. What does strong mean? The dots are closer to the line. So let's go ahead and actually do this backwards. We're going to do the line of best fit first. So I want both of these to be negative. So here's the line, here's me cheating, doing the line of best fit first. Negative, going down. Then I'm going to do my dots. I'm going to make this one weak. So remember, weak is they're going to go down, but further away from this line. But they're still generally going down. So now I can just do my dots on all sides of the line, going down just in a weaker fashion, like kind of further away. Okay, like that. All right, for this one, I need a negative correlation, so it's going down, but very close to the line of best fit. So we're just gonna, when we do these dots, we're just gonna do it real close to the line of best fit. Boom. Okay, so again, the difference between weak and strong is how far the data is from the line of best fit. All right, so that's how you do positive, that's how you do negative. Well, let's do not correlated. So there's no relationship at all. So a no correlation. So let's do no correlation, which means that you can't tell what the data is doing. So what we're going to do is just draw the data everywhere. Look at this. You can't tell if it's going up, down, or what it's doing. So this is no correlation. There's no relationship between what's happening on the X and what's happening on the Y. All right, the last one that we're going to do is let's do a perfect correlation. Okay, so let's do a perfect one. So perfect. And what that means is now we can do a positive one or a negative one. Let's do a negative one. So this is going to perfect, this one's going to be a perfect negative correlation. What that means is every dot is exactly on that line. All right, so every dot is exactly on that line. So it's not strong, but it's perfectly aligned, perfectly aligned. Strong is you do have dots or data outside your line of best fit, but perfectly strong is exactly on it. So that is your perfect correlation. All right, now the other thing that you can get is this is graphically represented the correlation, but we're also going to have an R value, and R value is how strong they are related to the data set. So let me quickly explain what that means. So you're going to have an R value, which is measuring the relationship, how strong it is, between -1 and 1. It is never going to be outside of -1, and it's never going to be outside of +1. If you get to if you get a +1, what kind of relationship do you think that is? Positive, right? And if you're a -1, what kind of relationship is that? Negative. Okay, so negative relationship, positive relationship. All right, now if the most you can get is 1, that must be my perfect correlation. Okay, so at 1, this is my perfect positive correlation. So we're just putting a number to how you're looking at the graph. All right, and obviously if I'm at my negative, this is my negative perfect correlation. All right, and if I want no correlation, what do you think that is? If -1 is my negative perfect and +1 is my perfect positive, where do you think no correlation is? It should be right at 0. So right at 0, no correlation. All right, so now in terms of weak and strong, okay, generally, now you'll get a little bit more detail in this when you do your statistics course. Generally, if you're between -0.5 and 0.5, that's going to be your weaker. Okay, and if you're outside, the closer you are to 1 on both sides, so even if it's negative, this is your stronger. All right, so this side is negative, and this side is positive. All right, so again, if you're close to -1, you are a strong negative correlation. If you're closer to +1, you are a strong positive correlation. And then in here, if you're here, so say you're at -0.3, you're a weak negative correlation. If you're at +0.3, you're a weak positive correlation. All right, now let's check to make sure that you understood that. What we are going to do is match the R value to the correct graph. So I'll do a few and then you do some. So let me do the first one. R is 0.98. So again, 0.98 is positive. So we're on this side of the graph, which is going to be positive. And then it's close to 1, right? 0.98 is here. So this is going to be a strong positive correlation. Which graph would that be? A strong positive correlation is right here. So this R value, so R is equal to 0.98 will belong to this graph. Okay, let me do another example. If I have, let's say, R is negative 0.28. So again, R is negative sits right here. 0.2 is underneath, or it's over here, it lies right here. So this is going to be a weak negative. So I'm looking for a weak negative. So these are the negative. The weaker one is the ones that data is further away. So that's going to be R is equal to negative 0.28. All right, so I've done these two for you. Please go ahead and do this one, and this one. And then I'll answer one of these for you. Okay, so what would the graph of R equals 1 look like? So remember, 1 is what? Perfect correlation. All right, so it's a positive, perfect fit or line of bet. It fits perfectly, okay? So you're going to answer these three and that one. All right, I'll do few of these in words now. So again, different representations, right? Graphs, numbers, and words. So I'll do the first 4 for you in these ones. All right, we're looking at how things are correlated, how things are related. All right, so here's the question: hours in the mall and the amount of money spent. Okay, so this is always going to be in general. So we can argue, like there's some people who are not going to do what I'm going to say. However, in general, the more hours you spend in the mall, the more money you will spend. So the more hours in the mall, the more money you would spend. All right, so what is this? Hours is increasing and money is also increasing. So if they're both increasing, as X is increasing, Y is also increasing, it is a positive, right? It is a positive relationship. So I'm going to circle A. Circle all the letters that belong to the correlation for the sentence back at the bottom of the page. All right, so I circle A because this is positive, positive. All right, let me do another one. How tall a person is and how fast they drive. Okay, how tall a person is. Can you say the taller a person, the faster they drive? Or can you say the taller the person, the slower they drive? No, this has got nothing to do with each other. So if it has nothing to do with each other, what correlation is that? None. So I'm going to circle B. And again, remember, this is just in general. This doesn't fit every single person. All right, another one, income and education. So again, think about it. The more income I have, is it true that I have more education? Or is it the more income I have, do I have less education? Or is it not related? Well, it's statistically proven the more income you have, the more education you have. So if they're both going in the same direction, X is increasing, Y is increasing, it's both positive. So this one is going to be a positive correlation. All right, distance traveled and the amount of gas in the car. So it's the last one I'll do. If I travel more, so if I go further, will my gas increase? Oh no, that doesn't make sense. All right, the further I go, will my gas decrease? Yes. Okay, so this one is a negative correlation because as one is going up, the other way is going down. So let me actually write that the way we wrote it here. As X is going up, so as we're going this way, what is Y doing? Y is going down. So it's going like this. So Y is going down. So we have a negative correlation for the distance traveled and the amount of gas in the car. So we're going to circle D. So please go ahead and finish E, F, G, H. Let's practice.